Hi, during this session I'm going to be considering weight, mass and inertial mass. So we asked the question, why do you weigh less on the moon? Okay. Now obviously this is because the gravitational field strength or gravitational attraction due to the moon is less than that on planet Earth, so therefore you feel less of an attraction. Now, quite often the terms weight and mass are misused, so I'm going to try and clarify what these terms really mean and how they should be used correctly by a scientist. So, what's the difference between mass and weight? Well, mass is a measure of how many particles there are in your body. It does not matter where you are in the universe, your mass does not change in any way. And obviously, the mass is measured in kilograms. Now, your weight is a measure of the pull of gravity on your body, and your weight does depend on which planet you're standing on. So you would weigh less on Mercury than on Earth because Mercury is smaller than Earth. Now, weight is measured in, as it's a force, so weight is going to be measured in newtons. Now they are interrelated, so if we think about a mass of 10 kilograms, then its weight is approximately 100 newtons. Now how do we make this link? Okay, so let me take you through the link. Okay. Your weight is in fact your mass multiplied by the gravitational force acting on each kilogram of you. So we've got weight equals mass times gravitational field strength for that location, and on planet Earth, at the surface, we have a gravitational field strength of 9.8 newtons per kilogram. On the moon, this will be 1.6 newtons per kilogram, which explains why your weight is less on the moon. So with that considered, no scientist should ever say that he weighs 50 kilograms. They should say they have a mass of 50 kilograms. Or vice versa, the scientist could say the gravitational force acting on his mass is around 500 newtons, or his weight is about 500 newtons. Now, I've got to emphasize here, I understand that common everyday language doesn't follow these criteria, but you've just got to remember, scientists know best, and that's the important thing to think about here. So, what do we actually experience? Well, if we had an elephant and a feather, and we decided to throw them off the top of a building, what we'd see there is that apparently the elephant would be falling much quicker than the feather. Now, our thinking would be that that means there's a larger force, makes it accelerate faster towards the Earth, and therefore the elephant hits the ground first. Now this is a misconception. Okay? What we really need to recognise is, if we think about Newton's second law, F equals ma, and recall that weight is mass times gravity. That means weight is a force, and mass times gravity is the force which causes an object to accelerate. So mass times gravity equals mass times the acceleration, and therefore we can say G is the gravitational acceleration. So the gravitational field strength of 9.8 newtons per kilogram is the same as the gravitational acceleration, which is 9.8 meters per second squared. So the mass cancels out and has no impact on the objects at all. It's actually, they're just going to accelerate at 9.8 meters per second. But that's only in the absence of air resistance. So we think about our elephant and our feather, air resistance comes into play, which is why we experience something which is different to what we calculate and what we think about in physics. So remember, if there's an absence of air resistance, then we can see that all objects would fall with exactly the same acceleration. Now, gravitational mass, which I mentioned before, can be derived from understanding what the weight is and what force is impact on it due to gravity. Okay, so what we really say is that weight equals gravitational mass times the gravitational field strength, G. Now I emphasize this because now I'm going to talk about something which is subtly different. Inertial mass. Now think about the mass of an object when it's giving resistance to a force. What we consider here is any time a force is applied to a body to change its motion, that means to produce acceleration, the is considered to be inertial mass. So this is the mass which responds to the change in force being applied to it. If we write Newton's second law, I guess that force equals inertial mass times acceleration. Now, what I'm saying here is that we've got this thing called inertial mass and we've got a thing called gravitational mass. And they seem to work in the same way. The greater the inertial mass, the harder it is to accelerate for a given strength of force. Now, think about it this way. If an object in a gravitational field, it responds to a gravitational mass, whilst an object is being pushed, it responds to an inertial mass. Now, these things don't necessarily have to be the same thing. However, the best scientists in the world have been able to perform lots of experiments and discover these two things are in fact identical, which makes a lot of sense for us, but there's some terminology to be aware of. So that is the difference between weight and mass and the difference between gravitational and inertial mass. I hope these things are now clear to help you move forward.